and Jupyter Notebook ID also will go through it. If time permits, we will start Python basics. Okay. So, how many of you already installed Anaconda in your machine?
Not it.
You have already installed Anaconda, right? Then
No,
you haven't
we
installed.
don't.
All right.
No.
So have you? Do
I,
you have any Python installations in your machine?
yes, I have.
So those who haven't installed Anaconda, I'll provide you I will explain you how to install Anaconda. But if you have any prior Python installations in your machine, uninstall it and restart the machine. If you have Anaconda already installed, then you don't require to install it again. You can leave it as it is. Okay.
Can we do this
But
after this call?
not during the session. Any instruction that I
Yeah.
provide. So you can
Yes.
watch the recording and then you can follow it. By tomorrow, make sure that you have everything been set up.
Yeah, that would be great. I think. Yeah. Thank you.
So I hope you this is clear. So those who haven't installed Anaconda, I will provide you how to install Anaconda, instructions to install Anaconda. But make sure that you don't have any prior installations before you install Anaconda. Uninstall it, go to control panel. Make sure that you have any Python install it, uninstall it, restart the machine, and then start following the instructions. Let me provide you how to install it. So those who are using Mac, you know how to uninstall it, right? You can simply drag the application and drop it in the recycle bin. So search for Anaconda download. So you can see that the first one, anaconda.com, it may not be the first link, but make sure that the website is www.anaconda.com. So click on download Anaconda distribution. So here you need to click on, so you can accept all when it comes to cookies. Click on get started. It may ask you to enter your email ID. So it's asking me to log in with my Google email ID. So I'm going to log in with my Google email ID. Or you can provide your own email ID over there. Sign up with email. There are two kinds of distribution. One is Anaconda distribution, another one is Miniconda. So don't install Miniconda. Miniconda is a lightweight version of Anaconda. So anyone who attends the session, I request not to attend from your mobile phones or tabs. Attend, use your laptop or desktop to attend a meeting. And any installation, say Anaconda need to be installed in your desktop or laptop. If you're using Mac, you have Mac version also. So choose one of this. Basically, not one of this. In fact, don't go with command line installer. Graphic installer. Previously, we had this Intel chips also, Intel chip support. Now they removed it completely. So only Apple Silicon. Apple Silicon means M1, M2, M4 kind of process. So Windows, you have only one. Click on that. It is installing. So you can, while installing, you can right click, open when done. So this is a old screenshot wherein they provide this Intel chip support also. Now they completely removed it. Let me check. Okay, it's resume. So wait, it got stopped for some reason. I'm going to resume it. So if you already have Python installed and if you try to install Anaconda, then it will create a lot of complex. So please don't complain about. So make sure that you don't have any Python installations in your machine. If you have, uninstall, restart the machine, and then follow these instructions. Anaconda installation procedure. Okay, its download has been completed. So it will open a window. So once the CXC been downloaded, even if you manually click on that, it will take some time. It will take few seconds to minutes. So a window will appear like this. Click on next. Click on I agree to accept the license agreement. Click on all users. When you click on next, now basically what happens is like it's going to open a window, something that doesn't appear here. So it says that once you click on next, it says that do you want to allow this app to make changes to your device? This is only for Windows users. Anaconda 3 installer. So you need to click on yes. That particular, the window that I just now told you that it will not appear on your screen. So that's the reason I specifically read that message. So you need to click on next, then you will get a window like this. By default, it's going to install in this path, C program data Anaconda 3. Stick to default path even if you are using Mac and stick to the same path. In my case, I already installed Anaconda in my machine. So if I go to the path, so you can see that a lot of binaries been installed in this. So I can't go with the same default path. So I'm going to add one to create a new unique name. But in your case, don't make any changes here. Okay, click on next. And then you need to uncheck this and you need to check this one. So click OK and check this again. Okay, and then you need to click on install. So in my case, I'm not going to click install, but I will show you the windows, what kind of windows that will appear after clicking install. So let me go to that documentation page. So once you click install, a progress bar will appear. Once it get completed, it will clearly show you a message completed. Click on next. And then click on next again. Don't make any, not to make any changes here. Just click next. And then there is a possibility that these two checkboxes may be already checked. Uncheck these two and then click finish. And then you need to copy these paths in environment variable. Whereas in the case of Mac, you don't require to add any environment variables. Let me tell you again that in the case of Mac, you don't require to add this to environment variables. By default, it will get added. So in Windows case, you have to add this to environment variables. So as I told you that stick to the default path where the Anaconda will get installed. So C program data Anaconda. They don't make any change to this. So only then these five, when you add these five paths to environment variables, you can able to access Jupyter Notebook. So you need to add these five paths one by one. So first of all, open environment variables, search for system environment variables. Here is the system environment variables. Click on environment variables. Here you can see path. Same way, if you scroll down here, there will be another path. in these two paths, you have to add these 5 paths. Okay. First of all, this is your specific and this system-wide specific. System-wide. So this is double click on this. Click on new, add path. Once you added that, so again copy the second path. Click on new, add path. Third one. Click on new, add path. In my case, I already added these 5 paths. 1, 2, 3, 4, 5. So you need to add one by one. Don't add it all together at once. So let me delete this. Once you added all the 5 paths by clicking new, click OK, and then come to this path. So path will not appear automatically. So you need to scroll down a bit so that you can see this path. Double click again, and then do the same thing. New, and then keep adding these paths one by one. So first one, this one. New path. And then new, add path. But in my case, I already added these 5 paths, right? Make sure that you add all these 5 paths. This is must, so don't ignore this step. Otherwise, you will face a lot of difficulties to access any tools or IDs that Anaconda provides. Once you add all the 5 paths, click OK. Click OK. There is a possibility that this apply button may get enabled. If it is enabled, if it's not enabled, that's fine. If it is enabled, click apply and then click OK. And then you need to restart your mission. So once you restart the mission, so the Anaconda installation part has been done. Okay. And then whatever the files that I share, so let me show you this one. Here, Python basics. 1 second, let me stop sharing for a while. Demo video, okay. Demo video. 1 second, someone posted a question. We will start session in 5 minutes, okay. Demo, all right. Demo video link is available in chat. Those who haven't watched or not attended session, I request you to watch the recording. That will give an overview of the content that we are going to discuss in this course. 3 or 3.5 months course. So let me stop sharing for a while. I will share a link to you in chat. Can you confirm it again whether you can be able to see my screen or not?
Yes, we can see your screen.
Yes, we can see that.
What about chart window? So I'm going to post a window. I don't know whether you can be able to see my chart window or not on the screen.
Yes, we can see.
I shared a Google Drive link. Click on that. That will allow you to download Python script, the script that I share. So you need to unzip it. You will get files like this. So the next few sessions are going to be on Python. And whatever the files that I share or the notes in the chat, you need to copy through Google Classroom. Once you enroll to the course, I will share the content through Google Classroom. Let me show you how it's going to be. Something like this. Right? So we'll get Google Classroom access once you enroll to the course. For now, you're not going to get access to Google Classroom. So any files that are necessary, things that I discuss during these 2 to 3 sessions, 3 sessions, I'll share it in chat. So download Python zip file. So what's going on? Just installation of Python only. Okay, click on that link and download it. And any files or notes that I share in chat or Google Classroom, save it in a common drive. So don't scatter out all the files. Okay, keep it in one common location. So by the end of the course, the space will take at least 300 to 500 gigs. So make sure that it's better to have a dedicated drive. If you don't have, make sure you have at least 300 to 500 gigs of free space. And save all the files, nodes, or whatever I posted in chat in that particular location. Okay. Everyone downloaded Python? Anyone has any difficulty to access Python or zip?
Downloaded, sir.
All right. So once you unzip it, you get files like this. Unzip it and get into this. You can see that .py, .ipy extension, .ipynb extension. IPYNB. IPYNB stands for IPython notebook. That's the original name of Jupyter notebook. Now we call it as Jupyter notebook. It is not JUPY, PI. It is not JUPI. It is JUPY. Jupyter notebook. The reason why they changed the name is initially it supports only Python. Then what happens is like they start adding support to other languages like JavaScript and all, Ruby, etc. So they're forced to change its name from IPython notebook to Jupyter notebook, but the extension is still IPYNB. Here you need to right click, open in terminal, in blank space, open in terminal. There is one way to open the terminal with the current path. So you can see the current path. When I say current path, this is what I mean, right? There is one way to open it, or else copy the path, open terminal, right click, run as administrator, cd space, enter. In some case, even if you change to this particular path, cd space, make sure that you add cd and then space. Don't blindly add the path. cd space the path. Sometimes this will not change to this path, the path that you intended to change. It still shows the old one. So in that case, it is in D drive, right? If it is in E drive, make sure that you mention E drive. But in my case, it's D drive. Just mention D colon, it automatically switch to this one. So that is one issue in Windows, but in Mac, you don't face such issues. Right? So once you got into this path, then Jupyter space notebook. And the easiest way to do it is right click, open in terminal, Jupyter space notebook. Again, make sure that it is JUPY, not JUPI. Enter. It will open a Jupyter notebook, which is a web-based IDE. You can see that all the files that you can see it here, it reflects here too, right? Suppose if you want to open a new, existing one, just click on this once. Then it will open a Jupyter notebook. So all the examples that I'm going to explain, you have all the notes right here itself. So while I'm going to explain Python concepts, I have my own workbook here. I'll open that, wherein it has a list of topics. I will start explaining, an example each. But in your case, you don't worry about notes. Open you already have the note, all the files here with detailed examples. My advice is like follow the video, create your own notebook. So here you can see top right corner, you can see new, right? You can see Python 3 IPU kernels. You're not going to have all this. So don't worry about this. Usually you will have Python 3 IPY kernel. Click on that. This will open a new notebook. So watch the recording and start follow along. Here, if you want to change the title of the Jupyter notebook, here you can see it's named as untitled 2, right? Click on that. Left click on that. Then you can change the name. Please mute yourself unless you have questions. My notebook. Unless it conflicts with the existing name, it basically renames it. So you can see that it has not been renamed because there is a file with the same name. So I need to give a unique name, my notebook. Please mute yourself. Thank you. So my notebook, maybe I will add some unique number, 99 something. Now it has been changed. As I told you that unless it conflicts with the existing name, usually it changes the name once you click on the rename. This is how you can give a title to your Jupyter notebook. Obviously, this will get reflect here. You can see that. And this is the code block, wherein you can enter some code, 2 plus 3 minus 5 by 8. Enter. Right? Enter is not simple enter, shift enter. There are two ways to execute it. One is shift enter. Another one is control enter. You need to hold the shift key and then enter. Otherwise, you can hold control key and enter. There is a subtle difference between shift enter and control enter. Usually you go with shift enter. So when you click shift, let me delete this again. Okay. When you click shift enter, what happens is like it is going to execute it. It's going to show the output. If it doesn't have any other block, code block, then it's going to automatically create one. In the case of shift enter. If it already exists, suppose if let's take that I have a code here, shift enter, it will simply move to the next one. It won't create a new one. It will create a new one only when there is no other block exists. Right? So that is one way of executing code block, shift enter. The other one is control enter. So if I do control enter, so what happens? It's going to execute. It shows the output right here, but it will not move to the next block. It's going to stick to the same block. You can see that control enter. I'm going to press hold control key and then enter. You can see that it got executed. The focus is right on the same block. It has not moved to the next one. Usually prefer to go from one block to another, right? In some case, we want to repeat the same block execution. So in such case, if you want to repeat the same block code execution, then you can use control enter. Or else predominantly we're going to use shift enter. Any questions on shift enter or control enter? How to execute these code blocks? You can see there is a code. It represents this is a code block. There are other blocks too, markdown. So markdown block is for documentation or adding titles or sub headings or subheadings. We'll see markdown blocks also. For now, we will stick to code block. So any questions on how to execute code block or how to write code? Then yeah, go ahead. Okay, the next one is
Sorry, Damodar, just wanted to check about the usage of Jupyter Notebook. Is it the preferred way of doing it in regular production environments, or we also use VS Code or any other IDEs for Python?
Yeah, I will explain about Visual Code later. Visual Code is definitely a preferred choice, but for now, stick to Jupyter Notebook. Keeping in mind, most of you are completely new to programming or new to Python. So I don't want to make things complex. In Visual Code, again, you need to set up virtual environment and all. That makes things complex. So definitely make you to go through Visual Code IDE, but not now. Stick to a simple IDE.
Okay, clear.
Okay, so suppose if you want to add a code block right on top of the existing one, so existing block right now, the focus is right now is in this block, right? If you want a block right on top of the existing one, then you need to press escape A. You can see that a block being created. If you want, let's take that 4 plus 8, right? If you want to add a block right under this block, I'm going to say a block between these two, then escape B. The reason why I'm pressing escape is if the focus is right in the block, you can see the focus is right inside the block, right? When these shortcuts A or B need to be, you need to make sure that the block is on the block. I mean, the focus is on the block, not inside the block. If you press escape, what happens is instead of having focus inside the block, it's going to go on top of the block. You can see that. right? Let me press it again, escape. If it's already, if the focus is already on the block itself, not inside, then you can simply mention A or B straight away. You not to press escape, but there's no harm in pressing escape. So let me press, the focus is right on the block, right? I'm going to press B. It's going to keep on adding blocks right under that. Same way, let me press escape. Now I'm going to press A. I'm not going to press escape anymore. Yeah. So it's going to create new blocks right on top of the existing one. Suppose if you want to delete a block, then you need to press escape. Let's consider in this case, do I need to press escape or not? Because the focus is right on the block, not inside the block. So I don't require to press escape. If it is inside the block, then you need to press escape. And then you need to press D twice. It is not case sensitive, by the way. I'm pressing D twice and it's going to keep on deleting those blocks. And here I don't require this block, so I'm going to press escape. The focus is on the block. D. Okay. That is how you can add a block right above the existing one or right below the existing one, and this is how we can delete it. So far so good, but if you want to add a comment, then you need to use hash. So let's take, this is an addition operation. You can use hash, and this entire text is going to be considered as comment. It's not going to be part of execution's lifecycle, right? And you can even add a comment, right? I guess this is addition. Basically, whenever you want to add a documentation, inline documentation is a good choice, but it's always preferred to have a separate dedicated markdown block. So let me create a block right on this one, escape A. Right? By default, this code block, right? You can switch between code to markdown or markdown code with this drop down. The shortcut is always preferred to go with shortcuts. Escape M to convert a code to markdown block, whereas escape Y is basically from markdown to code. Initially, you may feel a bit difficult, but stick to the shortcuts. So that will save a lot of time, especially when you write, when you start writing code. So this is code block, right? Let me press escape M. Now you can see the automatic switch to markdown. I haven't gone to this drop down and manually change it. So with this shortcut, I change from code to markdown. You can immediately see some change. There is no square brackets as such here, right? And you can add documentation to this. In this case, I want to add addition. Shift enter. Now you can see a proper heading. There are in fact 6 types of headings, just like the way we have it in HTML. Let me show you that. So heading 1, if you mention 2 hashes, there's going to be second type of heading, 3 hashes, 4 hashes, 5 hashes, 6 hashes. So you should not go beyond 6. Even if you try to go beyond 6, it will be considered as normal text. You can see this is not a heading. This is a normal text. You can even write normal text. Let's take this is a generative AI course. Normal text. You can give your own an explanation, a brief description of what this block does. So it's not just writing code. Documentation matters a lot. So readability matters. So you always need to write code in a way that is not just you can understand the code. It has to be accessible to your entire team. Even those who are not, not good at, or maybe they may not even know what is Python. So you have to write code in a way that even non-programmers or non-Python programmers can understand. Got it? So any questions on escape M or escape Y or the markdown block in general? You can even customize these things, but this is not essential. So don't don't deep dive into this. So it's not mandatory that you need to learn all this. If we, I don't know, yeah, this is a different kind of test. There are certain tags in that we use it in HTML works here. Not all, but some of these tags will work. Usually this is a bold text. Something like this. I don't remember it. Maybe this is not. Okay. We can write bullet points, by the way. Let's take option 1, option 2, as you can see. Looks like I made a mistake. Yeah, now you can see that the bullet points that we can add, or even sub-bullet points. Something like this. You can add bullet points too. But don't spend too much time on this, right? So I hope this part is clear. Let me post the shortcuts right here. Okay, Anaconda installation and setup has been completed, especially Anaconda. I have given an overview of Jupyter Notebook, IDE. And when it comes to Visual Code and other IDEs, we will see that later. For now, stick to Jupyter Notebook IDE. In fact, there is an installation guide. Let me show you. Somewhere around 120 pages. It has most of the installations here. The one that you are speaking out, Visual Code, right? Looks like there is, okay, yeah, here it is. Visual Code installations. It is being inverted a bit. Maybe I need to new tab. I have a rotation option right here. Looks like I don't have. So let me download this. Surprisingly, I don't see open with Google Chrome. Here I have rotation. Yeah. So the entire installation procedure of Visual Code also I'm going to explain, and even virtual environment store. So it will take roughly 20 to 30 minutes to explain Visual Code. But for now, I don't want to make things complex. So stick to Jupyter Notebook. Request you to stick to Jupyter Notebook. There are multiple IDEs, in fact. Even you can use Notepad as an IDE to write Python programming. But whatever. So we'll move on to Python basics. Any questions on this part? All right. So we'll move. Yeah, go ahead. All right. Next one, we'll start with operators. So we'll start with operators and then variables, dynamic types. We'll discuss a lot about Python. So next 4 or 5 sessions are going to be completely on Python itself, maybe more. So we'll start with operators. Bitwise operators are not necessary. There are certain bitwise operators like and, or, not. We'll discuss that as part of deep learning. So anyway, it's going to get repeated. So I don't want to discuss bitwise operators. So I'll skip that part. We'll discuss the remaining operators. In arithmetic operators, we have addition, subtraction, division, float division, maybe something new, especially those who are from non-Python background. We'll discuss what is float division. Modulo, which is nothing but a remainder part of the division. Multiplication and power off. So I will take two variables. Usually equal to is an assignment operator. We'll discuss that later, but for now we need two variables, x and y, wherein x has 5 value assigned to it, whereas y variable has 3 assigned to it, right? 1 second. Now x plus y. So it's not just confined to just two, variables. I mean, two operands. We call this as operands, and plus is an addition operator. We can expand to any number, something like this. We'll stick to a simple example. Okay, x plus y. So it's x is 5, y is 3 is equal to 8. So it will return value 8. The same way we have subtraction also, minus. So x is 5, y is 3. So 5 minus 3 is 2. Same way we have multiplication. So 5x is 5 multiplied by y is 3, y is 15. Right? That is multiplication. We can even go with division slash. So 5 divided by 3. So usually division, how it works. So 5 divided by 3 means 3, 5, 3 ones 3, the remainder is 2. But division, especially slash division, encourages basically it returns decimal values. So we can go with the point and we can add 0. So 3, 6, 18. Again, the remainder is 2. But as we already have decimal, we can add one more 0. So 3, 6, 18, another 18, and it's going to keep on going. So 1.6666. As long as, like, it depends on what is the precision being defined. So at the end, if we round it off, it's going to be 7. Let's see what kind of output we get here. So you can see that precision is a bit long here. And at the end, it's been rounded off. In mathematics, the same expression is going to be written like this, 1.6 bar. Bar means something, this value being repeated again and again continuously. There is no end to it. Okay. So there is something called x double slash y, which is nothing but float division. Before you understand float division, you need to understand what is floor and division. What is floor and seal value? Suppose if you have 5.2, the floor value is going to be 5.2 without decimal, which is equal to 5. Suppose if it is 4.8, so 4.8 without decimal. So this is floor value of 4.8. This is not, don't get confused with rounding a number. Rounding a number is different. Anything beyond equal to 5 or 0.5 or anything beyond 0.5 is going to be rounded as 5, right? I mean to say, so x point, let's take 5, is going to be rounded as x plus 1, whereas x point 4 or something like that is going to round it to x. But this is not rounding a number. Okay. So here, if I have taken floor 4.8, the floor value is going to be 4, whereas seal value is going to be 4.8 without decimal plus 1. So if you want to remember this, maybe initially you may have some difficulty. Just consider that this is a room. A 4.8 is right in between or somewhere in the room. This is seal. This is floor. The base of this 4.8 is 4. On top of it, the seal value is going to be 5. Right? That is how you need to visualize it. So the reason why I'm explaining floor value is this floor division. Floor division is nothing but division. Whatever the value that we get, which is round values, floor values. What is the floor value of 1.666 something?
One.
Simply 1 without decimal,
1.
right? What about seal value?
2.
Without decimal? +1. So 1 plus 1 is 2. So here it's going to give the floor values. You can see that 1. So always make sure there won't be any space between these two. But the space between this operator and the variables is completely your choice. It's optional. It improves readability if you add space, but don't add space in between. It throw an error. I hope this part is clear, right? We have seen multiplication, so we haven't seen modulo in power off. Let's see modulo. So if you go with division without decimal part, right? Let's take straight to this one, 313, 2 remainder part. Remember what this is the remainder, right? Modulo operator, which is nothing but percentage, will give the remainder part. Let me show you this. So modulo operator, what is the remainder? 2. Because it gives the remainder 2 here. Let's take I go with 4. Then 4 ones 4, the remainder is 1. Let's try that. So let me give 4. And I'm trying to find out the remainder. So you can see that it's 1. Modulo operator, which is nothing but percentage, represented with percentage symbol, will give the remainder part. The last one is power off. Suppose in mathematics, let's take 5 square. How do we write 5 square? Like this, right? Let's take 3 cube. 3 cube. Let's take 4 power 5. We write something like this. Whereas in Python, see this 5 square can be written as 5 double asterisk 2. Again, make sure that won't be any space between two asterisks. So 5 to the power 2. You can see that. There's a better way to do it. There is a library called math, wherein it has power, and the same 5 power 2 can be written as 5 comma 2, and you get the result. Even though this always written decimal with the decimal value. If it doesn't have any decimal value, it's going to point as 0.0. Whereas this one, unless this one of these values are decimals, it won't return the decimal. Suppose if I have something like this, then it's going to return decimal. There are two ways to do it. In fact, there are thousands of libraries, thousands of alternatives to get the same power. But this is the core Pythonic way of getting the power. 4 power 5, 4 power 5. How do we get 4 power 5? Like this. Or let's say 3 cube. So how do we write 3 cube? Like this. Right? Any questions on any of these operators? Addition, subtraction, division, floor division, modulo, multiplication, power off? Is this part clear?
Yes.
Those who are already into programming, you may feel a bit bored, but don't worry about it. Like we'll discuss more complex concepts in detail later. So initial 1 week or 1 or 2 weeks, we'll stick to the basics, and then we will move on to more advanced concepts. Right? All right. So there's only 10 minutes left, right? So discuss one important concept, that is logarithm and exponent. Have you heard about logarithm? Can anyone explain me what is a logarithm and why we need it? What and why we need it? what and why? And even exponent. If you use math library, then math.log is something that we use. Let's take that. Log 10 is 2.3 something. Math.e exponent, which is about 2.78 something. So what is this logarithm and exponent? In fact, if you look at logarithm, if you place cursor in between round brackets for any method or function, place cursor in between round brackets and press Shift Tab. Shift Tab is a way to get the documentation of that particular function or method. Because by default, the base is E. So when you look for 10, it's basically it is log 10 base E. Of course, you can explicitly change that base. Let's take 2. You'll get a totally different result because the base is 2 now. So what is logarithm and why we need logarithm? Even if it is wrong, that's fine. So go ahead and explain about your understanding on this topic. Logarithm and exponent. In school days, we would have seen this logarithmic book, isn't it? A blue book.
Yeah, long back. I don't remember exactly.
Okay. So something like this, right? This is a book. Small book. Of course, there are multiple versions of it. What is at least your intuition about logarithm? Even if you don't know about logarithm, that's fine. So yeah, this is the kind of book that you see. It used to cost around 5 or 6 rupees at that time in early 1990s, in my case. Nowadays, it may cost some 50 to 100 rupees. So let's take that you have 1 million records. So can you look at the data and can judge what is this data all about? Let's say that you have some multiple columns, maybe a single column, but you may have some 1 million records. Can you look at the data and can come to a conclusion or make a decision based on the data just by looking at it?
No.
Why? What is the reason?
It doesn't have any probably indexes or the information related to it.
What was that? I didn't get your point. So it may not have
Probably it doesn't
indexes.
have the proper indexes which describes what is the data.
Okay. Basically, just humanly, it is not possible for us to look at the data and understand. So we need tools. We need various methods or ways to understand it, right? One of the ways is visualization. Suppose I have same 1 million records of data. I got something like this. It is about profit. Now tell me whether the company is growing or is declining in terms of growth, I mean to say profit, year by year.
It's growing, yeah.
It's growing, even though there are some fluctuations here and there, right? Overall, it is an upward trend. What if the growth is like this? Is it growing or declining?
Yeah.
Declining.
Right. So it is definitely declining. So in order to get this visualization, we may have some tabular data wherein this may have some 1 million records or maybe 10,000, but it not to be 1 million or 10,000. Even if it is 100 records, it is very difficult for us to understand just by having a glance of it. We need some statistical methods, mean, median, mode, or some sort of visualization like this, right? So what if, okay, let me give an example. So what if the data is something like this? 1, 10, 100, 1,000, 10,000, 1 lakh. So how do we draw visualization? First of all, this is 1, right? This is 1. So where do we get 10? Do we get 10 here or somewhere else?
I think y-axis.
Your voice is a bit meager, so I'm not taking y-axis for now. So basically, I'm sticking to x-axis itself. So this value, so 1, the next value is 10, the next value is 100. So where do we get this 10 in this graph?
So it might be a linear position, I guess.
So your voice is a bit meager, so you need to check your microphone.
Sorry.
Okay, sure.
It might be linear. So
Linear. What do you mean by linear?
linear, like in between the x to y axis, we might be 10.
I'm only speaking about x-axis. I'm clearly telling you that it's x-axis. I have not spoken about the other axis. Other axis data point, I haven't given it. So in this case, where do I get the 10 or the 100 or 1,000? The distance here, the unit that I have taken is 1 only, right? If it is 2, then next point is going to be 4. But here I have taken 1. The next point, in order to map 10, somewhere it's going to be 10 here, isn't it? What about 100? I need to expand this.
I think we need to expand it.
So what is the purpose of visualization? So humanly, it's not possible for us to look at the data and have an understanding out of it, right? We can't come to a conclusion. We can't make a decision by looking at the data. So that is why we need some statistical methods or visualization. But what if the data is itself like this? Visualization is not going to be possible, right? Visualization on paper, on theoretical wise, like it may be possible. Practically, it's not possible to interpret this. So basically, when we have data in exponential form, it is not possible to draw a visualization. Let me take a good example. Seismograph. Have you heard about seismograph? You might have seen this in
Yes.
movies. What is this all about?
It recognizes the earthquakes.
Basically, it's a visualization drawn on a drum, a circular drum, right? So they say that on Richter scale, it is 5.2, right? Or 6.5, something like that. Basically, this 5.2 or 6.8 or 7. Let's take these two values. These are not the actual values. These are logarithmic values. Okay, let me explain this part. So in order to draw a visualization of this exponential data, so what do we do is, instead of taking the actual values, we'll take, so let's take 1 can be written as 10 power 0. 10 can be written as 10 power 1, right? 100 can be written as 10 square. 1,000 can be written as 10 cube. 10,000 can be written as 10 power 4. 1 lakh can be written as 10 power 5. What logarithm does is, here you can, if you look at this, the base is 10. The base is common 10. So you need to specifically write it as 10. And then if you apply logarithm on it, okay, logarithm base 10, 10 power 0 basically gives this power. Logarithm focus on power. So what about 10 power 1? What is the value? It is 1. What about 10 square? It is 2. 10 cube? It is 3. 10 power 4? It is 4. Base need not to be 10. In any scientific experiments, they don't take base as 10. They take it as E. Let's consider that USA has taken the base as 10. India has taken the base as 2. So whatever the value they communicate to us, we need to convert it into base 2, right? Again, the conversion will become difficult. So what they did is they come up with this constant math.t. That is the reason math.log, if you look at this documentation tab, by default it is base E. When they say the same rule applies for this one too. The graph that is being drawn on this drum is not on the actual values. It is logarithmic values because the data is going to expand exponentially. Whenever data goes exponentially, it is not possible to draw a visualization. So we go with the powers. I mean, we take some base and we take logarithm. When we say on Richter scale 5.2, which means the actual value is 181, 2.27 something. When we say on Richter scale 6.8, it is, you can see there's a huge difference between 181 and 897, right? On math.t to the 7.2. But the value 1339. If we draw with the actual values, this drum is not enough. This drum is, we need a very large drum. Even if you take a drum like this, it's not going to be enough. So whenever data grows exponentially, it is not possible to draw a visualization. So we observe the base. Usually we need to look at the data and understand what is the base. We need to come up with the base. But in most of the scientific experiments, they don't take 10, 2 or 5 as the base. They take math.e. So when they say vector scale 6.8, it is not 6.8. It is math.e power 6.8. This is the actual value. And 7.2, it's 1339, this one. So if we take this one, let's take, in order to come up with this value, what they do is they take this value, math.log, they provide this value. The base is what? E. So now we got this 5.2. Even if you don't mention it, by default it is E. Right? So if you give 897 something on Richter scale, it's 6 points. So this is what they communicate, and this is what they use it on, on this one. Draw visualization on this. I hope you got the point. If data grows exponentially, it is not possible to come up with a visualization. Visualization is one of the ways to understand data. So we can't have a look at the data and understand it straight away. We need certain statistical methods of visualization or both. So when the data grows exponentially, even visualization is not possible. That is when the logarithm comes into picture. Logarithm basically gives power. Base what? Base usually it's going to be E, but it's completely our choice. But usually it's going to be E. But we can switch to some 7, 10 or whatever. All the mathematical, any scientific experiment they do, they go with base E. That is exponent. That is how they came in with this kind of constant. So in order to avoid confusion, if one goes with 10, base 10, another goes with 2, another goes with 5, another goes with 4.5, the communication will become difficult. So let's take that you speak Telugu and I speak Hindi, someone speaks Tamil. So we are not going to have session, right? We need to decide and come to a conclusion that this is the standard language that we will have during the sessions, English in this case. Then everyone can start understanding it. And if you have any question, you can communicate back in English. That's exactly what math.e is about. Math.e is a constant. The scientific community came, with this value to have a standard communication. Clear? Can someone recollect what is logarithm and why we need it? Again, I will go back to this question. What and why we need it in 2 or 3 sentences. Why we need logarithm or exponent? Even if it is wrong, that's fine. So I'll correct it. Give it a try, that will be great.
The exponential values cannot be plotted in the graph. So we need to use the logarithm. Means we need to decide which is the nearest possible value, so that we can plot the graph approximately.
What do you mean by nearest value? Basically, you mean to say the crunching down the values instead of having like this.
Yes, yes.
If we take powers, basically we are crunching down all the values so that we can have a clear visualization.
Yes, yes.
Right? All right.
Yes.
So I hope you got an idea about logarithm and exponent, right?
Yes.
Okay, tomorrow we'll continue with Python basics.
Okay.
Make sure that you complete your installation part by tomorrow. If you have any
Yes.
difficulty, you can report it tomorrow.
Okay.
We'll sort it out.
Yeah.
So I hope everyone downloaded Python basics. Anyone has any difficulty or hasn't downloaded Python basics yet?
Download.
All right. If you don't have any questions, you can log off. We'll meet tomorrow, same time, same link.
Yeah.
Okay, thank you.
Damodar, did you provide
Yeah.
hello?
Yeah, go ahead. Go ahead.
Yeah, did you provide Anaconda installation guide?
What is that?
You had
Enough? Did I provide?
yeah.
What?
Did you provide Anaconda installation document?
I've been provided Encounter installation document, but the link will be shared. You can follow along.
Okay.
Yeah.
Thank you.
Yeah,
Yeah,
Damodar.
go ahead.
Can you provide yesterday's session recording? Actually, I could not attend yesterday's session.
It's already
Is it
posted.
available?
Yeah, it's posted right in the chat. So you can scroll up. You can see it here, right? Posted by Venkat sir.
Can you
So
share
let me,
it again, sir? I didn't
okay,
get
let
this
me
demo.
share. Yeah, let me share it again, and I will share the Python link also, and Jupyter Notebook shortcuts also. Anything else? Yeah, sure. Do you have any questions?
Yeah, in general, would you be able to share some experiences from the previous batches when they attend any interviews, how they are dealing the questions and what kind of questions that we get for these roles?
So basically, there are two blocks. In fact, we can say two categories of questions. One is on the concepts, predominantly the focus on transformed architecture. So even if I'm not undermining other concepts, but most of the models rely on transformed architecture. Predominantly, the questions are around transformed architecture. The second set of questions is what kind of environment you work on and share your experience on the projects. So the project that we discuss in this course, you can, if you're able to explain 5 to 6 minutes continuously, end to end, that will be good enough. So one is on projects and the experience that you have. The other one is on predominantly on transformed architecture, which is the backbone for all the models. So we'll discuss that in detail in this course.
Okay. And would you be able to cover whenever we are discussing the topics, right? Specific to in your experience, maybe you might have heard from the students who are attending the interviews from your previous batches. If you can cover the interview topics or questions from those scenarios, it would be helpful.
So my point is, don't prepare for interview. Instead, try to understand the concept. Let's take that logarithm itself. So I not to spend this much time in explaining logarithm. I can simply say the logarithm and exponent. The reason why I explain logarithm is, again, it's going to be used in matrix. If that question being asked, or if you are explaining about matrix, and if you speak about logarithm in detail, that will make you fluent in facing interviews. So while attending sessions, be interactive so that you can face interview quite naturally. So you not to bother about interview. Anyway, I will provide you interview questions, but be interactive. That's all. That's good enough.
Okay. Yeah, thank you.
Yes, someone else raised their hand. So anyone else has any questions? All right, if you don't have any questions, you can log off. We'll meet tomorrow at the same time with the same meeting link. Tomorrow's session is also a free one. And demo link, the previous session recording also been posted in the chat. Make sure you copy it. And WhatsApp community link also been provided. And the course content link also been provided over there. Apart from it, I have posted Python zip file. It's a Google Drive link. You can download it. Make sure you complete N8N installation by tomorrow. Thank you.
Okay, thank you.
Okay.
Yeah,
Thank you.
Thank you so much. Bye.